Constant and variable. In algebra, we use two types of symbols, constants and variables. Constant. A symbol which has a fixed numerical value is called a constant. Numbers 0, 1, 2 are constants. The smallest 3-digit number is a constant because it has fixed value, 100, etc. Variable. A symbol which can take various numerical values is called a variable. A variable is represented by a literal such as x, y, z, etc. As we know, the area of rectangle equals to L into B. Here, L and B are variables. Let us study the following matchstick pattern. Suppose we wish to form T's using matchsticks. We observe that number of matchsticks required is twice the number of T's to be made. This can be expressed mathematically as follows. Let the number of T's be n, then number of matchsticks required equals to 2 multiplied by n. 2 multiplied by n is conveniently written as 2n. Hence, number of matchsticks required equals to 2n. Clearly, n can take any of the values 1, 2, 3 and so on. This means n is not fixed and it can vary. Here n is called a variable. Hence, a quantity whose numerical value that keeps changing is a variable. Example 1. Look at the following matchstick. Look at the following matchstick pattern of squares. Observe the pattern and find the rule that gives the number of matchsticks in terms of the number of squares. So here is a pattern of matchsticks in the form of squares. So first of all, number of squares, let's look at our first figure in the given series. So number of squares is 1 and number of matchsticks are 1, 2, 3, 4. 4. So the pattern is 3 into 1 plus 1. Similarly, in the second figure, there are 2 squares and number of matchsticks are 1, 2, 3, 4, 5, 6 and 7. 7. So the pattern 3 into 2 plus 1. Similarly, next we have 3 squares and the number of matchsticks are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 3 multiplied by 3 plus 1. Next we have 4 squares and the number of matchsticks are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. And the pattern is 3 multiplied by 4 plus 1. As you can clearly see that the pattern is 3 multiplied by the number of square and plus 1. Here, the neighboring 2 squares have a common matchstick pattern. So therefore, we take 3 multiplied by 1 and add 1. So that's why in the first figure also we have not taken 4 into 1, we have taken 3 into 1 as 1 matchsticks becomes common when other square is added. So here you can see there are 6 unique 3 matchsticks of each square and 1 common matchstick of 2 squares. So therefore 3 multiplied by 2 plus 1, and here also there are 2 common matchsticks between 3 squares. So therefore 3 multiplied by 3 plus 1. You can see here the common matchsticks. Here is the 2 squares common matchstick is this, and in 3 squares the common matchstick is this. So we can say the number of matchsticks required is 3 multiplied by number of squares plus 1. So therefore, if there are If the number of squares is n, then the number of matchsticks is equal to 3 into n plus 1, that is 3n plus 1. So this is the general formula to count the number of matchsticks when there are n number of squares. So here is the pattern, and in each pattern we are given 4 figures in this pattern. So first figure, there is one square and number of matchsticks are 4, and the pattern is 3 multiplied by 1 plus 1. As one matchsticks becomes common, as we move on to our next figure, adding on more square to this square. Number of squares in second figure is 2 and the number of matchsticks are 7, so it becomes 3 multiplied by 2 plus 1. Now in the third figure there are 3 squares and the number of matchsticks are 10, so the pattern is 3 multiplied by 3 plus 1. And the next figure we have 4 squares, so our number of matchsticks are 13, so the pattern is 3 multiplied by 4 plus 1. So the number of matchsticks required is 3 multiplied by number of squares. As you can here also clearly see 3 multiplied by 1, as there is 1 square. So 3 multiplied by number of squares plus 1. If the number of squares is n, then the number of matchsticks is 3n plus 1. So this is the general formula to calculate the number of matchsticks when there are n number of squares.